Hey there, gang. In this next lesson, we'll take a look at how to solve one-step addition and subtraction equations. And so we're going to learn that to solve or find the solution to an equation, which is just the answer, we use what we call inverse operations. And what an inverse operation is it just is the opposite of the operation that you see. And so inverse operations undo the operations we see within the equation. Our goal for solving all of equations is to isolate the variable. So to isolate means to get it by itself. So when we solve equations, we want the variable to be by itself at the end. Okay, so we're looking at addition and subtraction equations today. So we should know that the inverse or opposite of addition is, of course, subtraction. And then vice versa, the opposite or inverse of subtraction is addition. So if we see an equation with addition, we'll use subtraction to isolate the variable. If we see an equation with subtraction, we'll use addition. We need to remember that equations are like balances. If you've ever used a balance beam in science class, when you're trying to get two parts to be the same weight or the same mass, you know that what you do to one side, you have to do to the other side of the balance in order to get the pans to even out. So equations are the same way. Whatever we do to the left side of an equation, we must also do to the right side, and vice versa. So let's look down at these few examples, 1 through 4, and talk about the work I want to see for you solving each of these equations. So number 1, we're given the equation x plus 13 equals 27. So our goal is to get, again, the variable x by itself. And over here on the left side, I see an x plus 13. So I need to do the inverse of addition to get rid of this plus 13. The inverse of addition is subtraction. So directly below the plus 13, I'm going to write a subtract 13. Okay, so on the left side of the equation, I've now subtracted 13. I'm going to do the same thing on the right side of the equation. Right below my 27, I'm also going to subtract 13. So I'm keeping my equation balanced when I do this. Subtract 13 on the left side, also subtract 13 on the right side. Now, when you're solving equations, I want you to go, again, vertically, and I want you to line up your equal signs. Okay, so my equal sign is up here in this equation. On my next line, I'm going to bring it straight down. And let's look what happens on the left side. On the left side, I have a positive 13, subtract 13, so those cancel each other out, so I'm just left with this x on the left side. So that x just comes down. On the right side, 27 minus 13 is 14, so I get x equals 14. What did I say the goal was for solving equations? To isolate the variable? Well, we've done that. The x is all by itself now on this side, so I can say that this is my answer, x equals 14. Now, when you're solving your equations, you should also check your solutions. So I do want you to show me that you're checking your answers. Okay, here's how we check our answers to equations. It's like the first lesson when we talked about how to find the solutions of equations. Well, if 14 is really my solution, I need to substitute it back in for my variable. So I'm going to substitute a 14 into this equation, 14 for x, and now I'm going to check to see if this is actually true. 14 plus 13 equals 27. 14 plus 13 is actually 27, so this does check out. So it doesn't take very long to check, but I do want you to write out your checks for each equation. Okay, number 2, we have the equation 18 equals 6 plus w. Again, this is an addition equation, so we'll use subtraction to isolate our variable. This time the variable's on the right side of the equation. It doesn't matter if the variable's on the left or the right. We can still solve the same way. So I see a 6 on the left side, or on the right side. I'm going to subtract the 6 from the right side, and then what I do to the right side, I must also do to the left side of the equation. So I'm also going to subtract 6 from the left side. Okay, so again, bring down your equal sign straight down. On the left side, 18 minus 6 is 12. On the right side, 6 minus 6 is 0. These cancel out, and so we're just left with our w. So we get 12 equals w, or that's the same thing as w equals 12. To check that, I need to take my original equation, 18 equals 6 plus, and this time W we believe is 12, and just be sure that makes sense. So 6 plus 12 is 18, and that checks out. Okay, looking at number 3, this time I have a subtraction equation, m minus 10 equals 2. Subtraction equations, I use addition to get rid of the subtraction. So over here, m subtract 10, I'm going to this time add 10 to undo my subtraction. So I'm doing that on the left side, and then on the right side I will also add 10 to keep my equation balanced. So now bring down my equal sign. On the left side, these 10's cancel. One is a negative 10, one is a positive 10, okay? And opposites will always cancel each other out. So we get an m here on the left side. 2 plus 10 is 12. Okay, so we get m equals 12. Let's check our answer. So we think m is 12. 12 minus 10 is equal to 2. And that is in fact true, so that checks. And then number 4, we also have a subtraction equation for this one. 7 equals b minus 3. I need to add 3 on the right side. Because of the subtraction, I also need to add 3 on the left side. So bring down my equal sign, and I get 7 plus 3 is 10 on the left side, equals this negative 3 and positive 3 cancel, so it just equals b. So 10 equals b. Let's check. So my equation was 7 equals b minus, 7 equals 10, 7 equals 10 minus 3, and 10 minus 3 is in fact 7. All right, so that's how I want to see you solving these one-step equations, okay, showing me if you're adding or subtracting, both on the left and the right, okay, keeping your equal signs lined up, and then also showing me your checks. Let's go to the back side now and look at the 2 word problems that we have for this lesson. So example 5 says a male gorilla weighs 379 pounds on average. This is 181 pounds more than the weight of the average female gorilla. And we're asked to write and solve an equation to find the weight of an average female gorilla. Well, the first thing we're always going to do for these word problems is we're going to do what we did in the last unit and write a let statement so that we can define a variable for what we're trying to find. So for this problem, it's asking us to find the weight of an average female gorilla. Okay, so I need to pick a variable. We could say W for this one. Write a let statement. So we could say let W equal the weight of our female gorilla. And now let's look at what we know in this problem. So the problem starts out telling us that the male gorilla weighs 379 pounds. So we know that a male, on average, weighs 379 pounds. Okay, what does it say after that? It says this is, so the 379 pounds is, okay, anytime you see is in a word problem, that signifies an equal sign. Okay, so our 379 here is equal to, this is how we write our equation, what? Well, it's equal to 181 pounds. Okay, so 181 pounds more than, well, what does more than mean in terms of math? It means plus, so 181 pounds more than the weight of a female gorilla. Well, we have our weight of a female gorilla because we've defined a variable. Our weight of a female gorilla is now W. So our equation is 379 equals 181 plus W. Okay, so anytime you're solving these word problems, again, it's a let statement, then an equation. And so now we can solve this equation for W based on what we talked about on the front side. This is an addition equation, so I need to subtract 181 from the right side and then I must also do that from the left side. And so that means my equal sign comes down. 379 minus 181. Well, 9 minus 1 is 8. And then 17 minus 8 is 9. And then 2 minus 1 is 1. So we get 198 equals 181 minus 181 is 0. So we get 198 equals W. As with all word problems, we're going to write a sentence for our answer. So we could say the weight of a female gorilla is 198 pounds. Okay, and then number 6, we'll do same thing, write a let statement and then write an equation and then solve that equation. So it says at age 25, German Titov of Russia was the youngest person to travel into space. This is 52 years less than the oldest person to travel in space, John Glenn. How old was John Glenn? Write and solve an equation. So again, we need to start out with a let statement based on what we're trying to find. What are we trying to find? We're trying to find how old was John Glenn. So we could say let J equal John Glenn's age. Okay, now let's look at what we know in the problem. Okay, well, we know that our first space traveler, German, however you say that, was 25 years old. Okay, so we'll start out with his age, 25. So it says 25, and then after it tells us that, it says this is. So this is, again, means an equal sign. So this means 25 equals 52 years less than. Well, anytime you see that phrase less than, okay, it means subtract the number in front of it. Okay, so 52 years less than means minus 52 in our equation. Okay, so it means I'm going to have some space here, and it means at the end of my equation I'm going to have a minus 52. Okay, that's what the less than means. 52 less than the oldest person to travel into space, which was John Glenn. Okay, well, how old was John Glenn? We don't know, so that's why we're using a J to represent his age. So that means that J goes in front of my minus 52. Okay, so this says 25 is 52 less than John Glenn's age. So there's my equation now, 25 equals J minus 52. To solve that, I need to use addition, so add 52 on the right side, and then add 52 also on the left side. Bring down my equal sign. 25 plus 52 is 77, so we get 77 equals J. So we could say John Glenn was 77 years old. Okay, as always, if you have any questions over this video, be sure you ask those the next time you see me in class. And until then, have a nice day. You're all wonderful people. Take care.